Welcome to EMI-BRAIN, your one-stop channel for tutorials that make learning simple, sharp, and successful.
Okay. Good morning, everyone. You're welcome to come forward now. Okay. You're welcome to this morning class. Today I'm looking at GCD. Particular today is GCD, and I'll make sure I round up this topic today. Are you following? There's nothing much about GCD. The word GCD means Greatest Common Divisor. It means what? Greatest Common Divisor. The greatest common divisor. That is GCD. It's also known as the word ACF. What is ACF? The highest common what? Huh? Highest common what? Factor, right? Now, right, put this on. GCD is defined as the highest positive integer. GCD is defined as the highest positive integer. The highest positive integer. GCD is defined as the highest positive what? Integer. Right there? That divides two or more numbers. That divides two or more positive numbers. That divide two or more positive what? Numbers. Without leaving a remainder. Without leaving what? A remainder. For example, listen. If you have to find a GCD of 8 and what? And 4. Let me GCD of 8 and 12. For instance, what is the highest number that can divide 8 and 4 without any remainder? 4. Are you following? Now, how do you get that 4? Watch. The factor of 8 can be 1, Abi. We have what here? 2, right? Can 3 divide 8? No. What's the next one? 4. What's the next one? 8 itself. Let's take that of what here? 12. What's the first number? 1, Abi. What is second? 2. What is third? 3. 4, right? 6 and what here? And 12. These are the factors of what? Of 8 and what? And 10. Now let's bring out the common factor here. What's the common factor between them? The common factor between them. What are they? 1, Abi. What again? 2. What again? And 4, right? Right there. Then the next is to bring out what? The greatest what? Common what? Divisor, or the greatest common factor. These are the factors of what? The common factor of 8 and 1 and 12. But the greatest here is what? Is what? Is 4. Are you seeing it now? These are just simple way of finding what? GCD. But there are some bigger numbers that we cannot calculate their GCD by bringing out what? Their factor. Are you following? But we look at those other numbers. Yeah, put this out. There are methods of finding GCD. Methods. Most of the time it comes this way. The first one should be what? Listing the factor. Number 1. Number 2 should be prime what? Factorization. Number 3 should be what? Repeated what? Subtraction. The fourth one is what? Euclidean what? Algorithm. You can arrange it that way. The first should be what? Listing the factors method. Like we just did now. Are you following? GCD of 8 and 12. 8 and 12. The factors of 8 are what? 1, 2, 4, and 8. Are you following? The factors of 12 are what? 1, 2, 3, 4, 6, and what? And 12. Are you there? Then the common factor between 8 and 12, we agree is what? 1, 2, 4. Then the greatest common factor or divisor is what there? Is 4. Are you there? We call this what? This other word there? Listing. Are you there? Listing the what? The factor what? Method. This is under listing the factor method. But one thing you should take note of, GCD means that number, that positive number that can divide 2 or more what? Positive number, right? Without leaving what? A remainder. Without having what? A remainder. Are you there? That's the knowledge you should have. Now let's look at prime what, yeah? But let me give an example, then we'll move forward. If you have to find, can I clear? Can I clear? If you have to find the GCD of 40 and and 30. The GCD of 40 and 30 using the listing the factor method. Now let's find the GCD of 40 and 30. Solution to this. What are the factors of 40? 1, 2, 4, 8. Can 40 divide 8 without any remainder? What again? 10. What again? No? 40 is 7, right? Are you there? 20, thank you. After 10 should be 20. Followed by what? 40. What's the next one there? For 30. 30 is what? 1, 2, 3, 5, 6, 10. Okay. 15, thank you. And what again? 30 is 7, right? Now the next is to bring out what, yeah? The common what? The common factors. Which are what? Between these two, what are the common factors? 1, 2, 5, 10, right? That is all. Then the next is what? The greatest common what? Divisor. Or the greatest common factor. Among these four numbers, which is the greatest among them? That means my GCD is what? Is 10. Therefore, GCD of what? Of 40 and what? And 30. Which is always in this form. GCD 40 comma what? 30 is equal to what? Somebody? 10. When you see this kind of question, GCD, then we have 40 and 30. That means GCD of what? 40 and what? And 30 is equal to what? Yeah? 10. For this is simple, right? Let's go into prime factorization method. Prime what? Factorization. Collect me here? It'll be fast, right? One is prime factorization method, right? I want to believe we all know what is prime numbers. What are prime numbers? Numbers greater than 1, right? That have just two components, 1 and what? And itself. Is that not? Is that not? Number greater than 1 that has two positive numbers when dividing them. Now we can only divide them with 1 and what? And itself. For example, now 1 is not a prime number. 1 can only divide itself. Right? Number 2 is what? 1 is not. It's still a prime number. It's still a prime number. Yes. Why? Because 2 can divide itself. What is 2 over what? 2. 1, Abi? 2 can also divide what? 1. What do you have there? 2. What about 3? Yes. 3 can divide what? 1. And what again? Itself only. Are you following? What about 4? No. 4 is not a prime. 4 though can divide itself. Abi? To give us what? 1. 4 can also divide what? 1. To give us what? 4. Or can also divide what? 2 to give us what? 2. So 4 itself has how many divisors? 1, 2, 3. 3 divisors. Prime numbers, they have just 2 divisors. 1 and what? And itself. Is that making sense now? So 1 itself is not a prime number. But 2 is a prime number because 2 can divide itself. Also divide what? 1. What of 4? No. 4 can divide itself. Yes. Can divide 1. Yes. But can also divide what? And that number. Are you following now? What of 5? Yes. It's a prime number. Why? Can divide itself. Divide 1 only. Right? Are you following? What the next one? Is 6 a prime number? No. What the next one there? 7. Right? What the next one there? Is 8 a prime number? No. Is 9 a prime number? No. 9 can divide 1 to give us 9, Abi. 9 can divide itself to give us what? 1, right? 9 can also divide what? 3. So 9 is not a prime number. Because 9 has how many divisors? 3 divisors. Is that clear? What the next prime? 11. What the next prime? 13. What the next prime? Is 14 a prime number? No. What of 15? No. What of 17? Yes. You know them, right? ETC. Are you following now? Good. These are prime numbers. Now let's see what we call prime factorization method. For example, yeah, money. If you find the GCD of, let's say 8 and what again? 12. Using what? Prime what? factorization method. What do we do here? I'll bring out the prime factors of 8. Let me show you how we can even do this. Look at this. If I have 8 here, what can divide 8? 2, Abi? 2 in 8 is what? Yeah? 4. Are you there? What can go again in 4? Is 2, Abi? Are you getting it? Or let me put it here. 2 here will give us what here? 4, Abi? 2 here we have 4. What can go here? 2 again we have what here? 2, Abi? What can go again? 2 we have what here? 1. Are you there? So that means to generate the factors of what? Of 8. What do you have? That will give us what? How many 2 do we have here? 1, 2, 3, Abi? That will give us 2 times what here? 2 times what? 2. The prime factors of 8. If I have 8, divide 4 by 8. What do you have is 2, Abi? Sorry. Divide 2 by 4 by 8. What do you have? Is 4. That means the first number is what is 2. Further divide again. What do you have? 2. Is that not? Divide, what do you have again? You have again? 1, Abi? That means that how many 2 can we generate in 8? 3. 2 times 2 times 2 is what? Is 8. So that means that the factors of 8 is what? 2 times 2 times what? 2. Although we say 3 is the factor, but I can't generate 3 here. If I say 2 times 3, what do you have? What 2 times 3? 2 times 3 is what? 6. 6 times 1 will give us 8, nothing. So the only number we can use to generate the factors of 8 are what? Just 3, 2, Abi, which is what? 2 times 2 times what here? 2. Are you there? Are you following? Okay. What about that of 12? Let's take out of 12 here. What can go in 12 here? 2, Abi? What do you have here? 4, Abi? Sorry, 6, sorry. What can go in 6 here? 2. What do you have here? 3. What can go again? 3. What do you have here? So how many prime factors can we generate from 12? 2 and 3. 2 times what? 2 times what? Times what? What's 2 times 2? 4. What's 4 times 3? 12, Abi? That means we have 2 times 2 times what? 3. What? 2 times what? 2 times what? 3. See it here now. We have 12, Abi? Divide 2 by 2, what do you have? 6. Divide 2 here, what do you have? 3. Divide what now? 3, what do you have? That means we have 2, 2, what? 2. 2 times 2 is 4. What 4 times what? 3. That will give us what? 12. Are you getting the gist here? Huh? Are you getting the gist? No, I'm just showing you the easiest way to do it. It's confusing. Okay, if you can make to generate the factors, but make sure you're using what? The prime what? Factors. Are you there? 2 and 3 are prime factors. Hope you're aware. Are they prime factors? They are. Is that not? Oh yeah, what? Let's go. This can be factorized. Now, this is where the word factorization comes in. I can factorize this 2 as what? 2 raised to 1, 3. Abi? Are you aware? What about this? 2 raised to 2 times what? Yeah? 3. Are you getting this here? Now, between this and this, what is common among them? No. What's common there? 2 raised to 2 is common here, right? Also common here. Here we have 2 raised to 2. Here we have what? 3. Is that 3 here? So 3 is not common. Are you following? But we have what? 2 raised to 2. What do we have here? 2 raised to 3. We can generate 12 from here. This is also the what? 2 raised to 2 times what? 2, Abi? So we have this as a common factor. So the answer here is what? Is 4. So GCD of 8 and 12 is what? Is 4. Because 2 raised to 2 is what? Is 4. Guys, solve this one. Let me see your answer. Using prime factorization method, find the GCD of 60 and 48. 60 and 48. GCD of 60 and 48. Let's bring out the prime factor of 60. What do we have there? Let's try my speed again. 60, right? What can go here? 2, right? What do you have here? 30. What can go here? 2 can still go, right? What do you have? 15. What can go again? 3 can still go, right? Is that not? 3 is a factor. It's a prime number, right? What can go here? 3. What do you have here? 5. What can go again? 5. What do you have here? 1. Are you seeing what I'm doing now? 2 times 2 is what? Times 3, 12. 12 times 5 is what? 60. So can we say that the factors of 60 are what? 2 times what? 2 times what? 3 times what now? 5, right? Are you following? Which is the same now. Let me leave this way. What's the next one here? 48, right? The factors of 48. 48. What can go here? 2. What do you have here? 24, right? What can go here? 2. What do you have here? 12. What can go here? 2 again. What do you have here? 6. What can go here? 2. What do you have? What can go again? 3. What do you have? 1. So what do you have there? Let's look at the factors here. 2 times what? 2 times what? 2 times what? 2 times what? 3. Will that give us 48? 2 times 2 is 4, right? 4 times 2 is what? 8. What's 8 times 2? Times 3. 48. Are you getting this now? So let's get to the common. 1, Abi. Are you saying it now? What do you have again? And that one, Abi. Are you there? What do you have there? 3. So what's the answer here? 2 times what? 2 times what? 3. What's the answer here? 12. Therefore, the GCD of what? Of 60 and what? 48 is what? 12. GCD of 60 and 48 is 12. So let's use that method now. Let's factorize it. Let's see. What would it give us? 3 raised power 2 times what? 3 times what? 5, right? What about this? 3 raised power 2 times what? 2, Abi? 3 raised power 2 times what? 2 raised power what? Yeah? 2, right? Times 3. Is that not? Is that not? So what do you have here? And what again? 3. You give us 4, Abi? 4 times what? 3 equals what? 12. Okay, what's the next one? Repeated what? Subtraction method, right? Repeated subtraction method. Are you there? Are you following? Huh? Oh, yeah, put it down. Let me give a note under this. Under repeated subtraction method, right? Subtract the smaller number from the larger repeatedly. Subtract the smaller number from the larger repeatedly until the two numbers become equal. Subtract the smaller number from the larger repeatedly until the two numbers become what? Equal. Either the result is the GCD. The result is the what? GCD. The result is the GCD. Let's find this. GCD of 60 and what? 48. Huh? Using what now? Using repeated, right? Subtraction what? Method. Huh? Very simple. What is the principle I gave you there in the notes? You subtract what? Smaller from what? The larger, right? Repeatedly. Between 60 and 48, which is larger, which is smaller? 60 is larger, right? So I'm going to have what here? 60 minus what? 48, right? And what do we have here? We have 12, right? We then ask ourselves again, between 48 and 12, which is larger? 48. I'll come again and say 48 minus what? 12. What do you have here? Give me the value. What do you have? 30 what? Are you sure? 36. What do you do again? You subtract what again here? 36 minus what? 12. What do you have? Minus 12. What do you have? 20 what? 4. Huh? We subtract again. 24 minus what? Yeah? 12. What do you have? 12. What do you have again? 12 minus what? 12. What do you have? 0. Therefore, GCD is what? 12. Is that clear? You didn't get it. Subtract the bigger, the smaller from the bigger until 2 becomes what? Equal. We are there equal, yeah, B? And that gives us 0. That number that comes before that 0 becomes your GCD. I will still explain again. So what we did here? 60 minus 48 is what? Is what? 12, Abi? Between these two again, which is bigger? This, Abi? Here becomes what? 48 minus what? 12. What do you have? 36. Are you following? What do you have here? 36 minus what? 12. What do you have? 24. Here becomes what? 24 minus what? 12. What do you have? 12. Here becomes 12 minus 12. What do you have? 0. Therefore, GCD becomes what? If my 0 is here, what's my GCD? 24. Are you following? Or you have solved this for me, all of you? Find the GCD of 48 and 18 using repeated subtraction method. Using repeated subtraction what? Method. Let's solve it together. 48 and what? And what there? 18. So what do we do here? We have 48, right? Minus 18. What do you have here? Huh? We have what? 30, right? Are you following? What do we have? 30 minus what? 18. What do you have? 12. What is the next one now? 18 minus what? 12. What do you have? 6. What is the next one? 12. Minus what? 6. What do you have? 6. What is the next now? 6 minus 6. What do you have? GCD becomes what, yeah? 6. Our GCD is 6. Huh? Is that clear? Okay. The main one, Euclidean algorithm. Oh yeah, please write down. According to the Euclidean algorithm method, the GCD of two numbers, is what? Please pay attention. Find the GCD of what was the last example I gave us? 60 and what? Huh? 60 and 48, right? Using what? Euclidean algorithm. Huh? Algorithm. Using the Euclidean algorithm method. Now pay attention. To solve this solution, between 60 and 48, which is bigger? 60, right? That means 60 represents what? Our A. What's 48? B. Because we say A is greater than what? B. All the time. Are you following? So that means that here becomes what? Let me use this side. Watch. Here becomes what? Or recall that A equals to what? Yeah? BP plus what? R, right? Let's go. What's our age, yeah? 60. Where A is 60, right? B is what, yeah? 48. So we have 60 is equals to what? What be here? 48. But we don't know what is our quotient, Abi? Divide 60 by 48. What do you have? To find your quotient, quotient is the result of those division, right? When you divide 60 by 48, what do you have? 1.2 what? 5. That means my quotient is 1, but then that's something, Abi? Is that not? So I have what here? 1, which represents what? Our Q. Then what do you have here? Plus. Let's bring out what? Our remainder. How do you get your remainder? No. Watch. Let me teach you. No. We have 1 here, right? Multiply that 1 by 48. What do you have? Subtract 60 from that number. What do you have? 12. So I have remainder what? Yeah? 12. I will extend this one here. And extend this one here. 48 and 12. Which is bigger? 48. 48 will now represent what? Yeah, my A. Are you saying it? Equals to what? Here becomes what? Our B. Huh? What will be the quotient? I will divide again, Abi. 48 by what? By 12. What do you have? Divide now. 3 or 4. Remember what? We have 4, Abi. Remember what, yeah? 0. Therefore, my GCD is what? 12. There are some time we keep on dividing until you have what? 0 remainder. Once you have your 0 remainder, that number that comes before that 0 becomes your what? Your GCD. So what's our GCD here? Is what? 12. Therefore, GCD of what? Of what? 60, what? 48 is equal to what? Yeah? 12. Is that the answer? Using the prime factorization method. Okay, so put this down. Yes, ask a question. This 60, I've divided this now with this. Right? We divided what first? 60 divided by what? 48. That gave us something, 1 point something, right? I've already divided now. So I now have remainder what? We have 4, right? Where is it? We have 1 remainder what? Yeah? 12. Let me know how you got 12. Are you sure? Are you sure? We have 12. Then I have to extend, because I'm dealing with Euclidean algorithm. I will extend this 48 here. 48 will now replace what here? 60. 12 will now replace 48 with what? 12. I will further divide again. I will divide 48 by 12. What do you have? We now have what? 4. Remember what? 0. The answer is 4. Remember 0. So what are GCD? 12. So we have 12 as our GCD there. Right there? Let's see more complex example. Okay, right, please. More complex example. Find the GCD of 1071 and 462. Now to solve this, listen. The GCD of 1071 Abi and what? 462. Where A is greater than what? Yeah? B, right? Is what's the formula there? A equals to what? BQ plus what? R. Are you following? Eh? What's that A? 1071 equals to, now what's that B? 462. Let's find our quotients. What do you do? 1071 divided by what? 462 is what? 2 point something, Abi. So my quotient is what? 2. Remember what? How do you get remainder? Multiply 2 by what? 462. What do you have? So that means 1071 minus what? 1 10. What do you have now? 1848. Are you sure? 462 times 2. 924. What do you have there? 1. What the value when you subtract? 147. 147. So what's our remainder now? 147, right? Now what do you say will happen? Between this, which is bigger, this I will extend this here. I will do what here? Extend this here. Are you following now? So what will be here now? 462, right? Equals to what? What will be here? 147. What is our quotient? What do we do? We divide again, Abi. We divide 462 by what? 147. And what do you have? 3 point something. Eh? So 3. Remember what now? Multiply 3 by 147. What do you have? So 462 minus what? 441. Hope you know how we got this. 3 times 147 is what? 441. So subtract from this, right? What do you have? 21. So plus what here? 21. I will still extend again, right? I will extend again. So when you extend, what do you have here? 147 equals to what? 21. What will be your quotient? Let's go. 7. Thank you. Remember what? Thank you. Remember 0. Hope you know why. When you divide 147 by what? 21. We got what? 7. Remember what? 0. So what do you think is our GCD? Thank you. 21. Therefore, our GCD Our GCD is what? 21. Therefore, GCD of 1071, 462 is equal to what? Yeah, 21. Now let's look at this other example. Let me resolve for those who could not get it, right? We have to find a GCD of 56 and 98 using the Euclidean algorithm method. The formula says what? Yeah, A equals to what? B Q2 plus R, right? Where A is greater than what? Yeah, B. What's that A there? 98 equals to what's that B? 56. Divide 98 by 56. What do you have? 1 point something, right? 1 point something. So we have 1 as the quotient. Remember what? 42. How do we get 42? Multiply 1 by 56. We have 56, Abi. Then subtract that value from 98. That will give us what? 42. So I will extend, right? I will extend it, yeah? So what do you have here, yeah? 56 equals to what? 42 times what, yeah? What's our quotient here? 56 divided by what? 42. Give us 1 point something. So we have 1. Remember what? 14. Are you sure? So what do we do again? We extend, right? We extend. What do you do to find the value, yeah? You have the what? 42 equals to what? 14 times what, yeah? Times 3. Plus what? Plus 0. How do we get this? 42 divided by what? 14. We give us what? 3. Remember what? 0. Right? So that means our GCD is what? 14. So GCD of 98, what? 56 is equal to what there? 14. Okay, the next question is actually this. Given that D equals to 120S1 plus 23S2, right? Find the GCD of what? 120 and what? 23. And find the value of what? S1 and what? And S2. Right there? Now, what we have to do first is, we have to apply the Euclidean what? Algorithm method. Get the GCD. Get what? The GCD. When you get the GCD, we'll now do what we call linear combination. Linear what? Combination. What is a linear combination? It's just like an expression that has a relationship with what? With this equation given to us. This is their own linear what? Combination. What you have to do is that after getting your GCD, get your own linear what? Combination. Then compare your own with their own to get the value of what? S1 and what? And S2. Are you following? Now let's start. Solution to this. GCD of what? 120, right? And what? 23. Where A is greater than what? B is calculated by using what formula? A equals to what? BQ plus what? R, right? Yeah, A is what? Greater than B, right? What's that A, yeah? 120 equal. What's that B? 23. Divide 120 by 23. What do you have? 5 point something. So we have what? 5, right? Remember what? 5 times 23 is what? So 120 minus what? 115. Abi? Is what? Are you sure it's 5? Remember what? Yeah? 5. Are you there? So what do we do now? We have to extend, right? We have to do what? Yeah? Extend. When you extend, what do you have here? 23 is equals to what? Yeah? 5, right? What do you think will be the quotient here? 23 over 5 give us what? 4 point something, right? So we have 4. Remember what? 5 times 4 is what? 20. 23 minus 20 is what? 3. So remember what? Yeah? 3. So what do we do again? We have to extend, right? We extend. Are you following? What do we have? 5 equals to what? Yeah? 3. So divide 5 by what? 3. What do you have? 1. Remember what? 2. Are you sure? So we have 1 plus what? Yeah? 2. Right? What do we do again? We have to keep on extending, right? Until we have 0 what? Remember? What do we have? 3 equals to what? Yeah? 2. 1. Remember what again? 1. So we extend again. Abi, what do you have? 2. Equals to what? 1. 2. Remember what? Are you sure? What does GCD now? 1. My GCD becomes this. This is my GCD, right? Okay. So GCD of 120 comma what? 23 is simply what? 1. Is simply what? 1. Now listen now. We have solved the first, Abi. Are you there? We now have to find what? The value of what now? S1 and what? S2. Now what we are going to do is this. We have to rewrite. We do what? Rewrite what? The equation. Do what? The equation. Starting from the GCD. What is GCD here? This. Let me remove this box. So rewrite simply means I will make this number here as what? Subject of the formula. Watch. If I should make 1 as subject, what will it be? 1 equals to what? 3, Abi. When you move it, it becomes what? Minus 2 times 1. 1 is equals to what? What do you have here? 3, right? Minus what? 2 times 1. Equation 1 here? 1. Let's rewrite this. When you write, what do you have? 2 equals to what? 5. Minus what? 3 times what? 1. Are you following? Equation what? Who is not following? Let me see hand up. You're not following. From where? From here. We are rewriting the equation starting from the GCD. This is our GCD, Abi. Are you there? Means I'll make 1 as what? A subject of a formula. Huh? Yes, watch. When you move a number, a positive number across an equal sign, the sign will change now. Is that not? If I have this in mathematics, let's say I have x is equals to what? Y minus 3 or y plus 3. Huh? Time to move this y becomes what? X minus y equals to what? 3. Is that not? Huh? When you move a positive number across an equal sign, the sign becomes what? Negative. When you move a negative number, becomes what? Positive. Huh? So here we're making 1, 2, 3, and 5. As what? As what? Of the formula to stand alone. So what do you have here? Let's go. 1 is equals to what again? Where is it? 3, right? Minus what? 2 times 1. What about this? 2 equals to what? 5 minus what? 3 times 1. What about this? 3 is equals to what? 23 minus what? Times 4. Equation what? 3. What about this? 5 is equals to what? 120 minus what? Equation what? What again? That's the last, Abi. Yes. Please pay attention. The next, we have to conduct what we call backward what? Substitution. Backward what? Substitution. Please pay attention. This is what you'll be seeing in your exam. Not all those one. Find GCD. They will only give you an equation like this. They'll say find a GCD of the two numbers and find their what unknown. Are you getting it? Okay, now let's proceed now. Now what? Backward substitution. Look at this. This is not the normal way of substituting equation. Normal way is forward. But this is what? Backward. I'm just like, I will put equation 2 into equation what? 1. And get what? Equation what? 5. No, we stop at what? 4, Abi? When you put 2 into what? 1. That will give us a new what? Equation. We call it equation what? 5. Are you there? I will now put equation 3 into equation what? Equation what? 5. That 5 we got. And call it what? Equation what? 6. I will now put equation what? 4 into equation what? 6 and call it what? 7. It's called backward what? Substitution. Can we try it out? Oh yeah, watch now. Now you following? Okay. So we say put. Are you following? Put equation what? 2 into what? Equation 1. 1 is saying what first? 1 equals to what? 3 minus what? 2 times 1. Abi? The quantity. If I'm to put equation 2 into what? Equation 1. That means anywhere I see 2 in equation 1, I'll put this, Abi. Is that not? So that will give us what here? Let's go. 1 equals to what? 3 minus. What do you have there? This is minus 2. So the minus sign is affecting every value here, Abi. That will give us what? Let's go. 5 minus 3 times 1. Times what here? 1. Abi, this one. Now listen. I want to put equation 2 into equation 1. Meaning, anywhere I see 2 in equation 1, I'll put this, Abi. Do we have 2 here? I'm putting this into this. Meaning, I will substitute this value, right? into this equation here. And question 1 says what? 1 equals to what? 3 minus 2 times what? 1. What do you say question 2 is? 2 abi equals to this. Which is what? I have 1 abi equals to what? 3 minus. What is 2 there? 5 minus 3 times 1. Abi? Is that not? Here we have what already, yeah? We have 1. I only substituted what? The whole of this, right? Into what? This here. So we still have what here? 1. Are you following somebody? Don't throw away this one. Sometimes we can have 2 here, don't forget. Is that not? We can have 4, we can have 5. But here we have what? Times what? 1. Is that clear now? Can I continue? What we have to do is to expand this. This is 3. 1 equals to what? 3 minus 5 plus 3 times what? 1. Huh? Are you following? Okay, let me just show you something. Listen. Listen. This times 1 here is affecting both 5 and what? And 3, abi? Is that not? When I have 2 numbers in bracket multiplying a particular factor, that factor we multiply those 2 what? Numbers. So the factor here was what? Can I say this is the same as 3 minus 5 times 1? Eh? What will be here? Plus 3 times 1. What is 1 times 1? 1. Eh? Are you following? Yes. I expanded now. 5 times 1 is what? Is 5 times 1, abi? What is plus times minus? Plus. This one here, we multiply this one here. What do you have? 3 times 1. Are you there, somebody? Even if I have 2 here, eh? These 2 will not multiply 3, oh. To only multiply what? This 1. That will give us what? 3 times 2. So what do you have here? We have 1 back. What will be here? 1. Yes, ask your question. Okay. Now, listen now. Eh? Are you following? Can I continue? Do you know I can also represent? Look at this. What do you notice here? We have 5 times 1, we have 3 times 1, abi? But yes, what? 3. 3 times what will give us 3? 3 times 1. To make them homogeneous, meaning the same. It's not really good to leave this as 3. Even if I have times 2, that remains what? 3 times what? 1. I can as well say this is the same as what? 1 equals to what? 3 times 1 minus what? 5 times 1 plus what? 3 times 1. Have I changed anything here? No. Because 3 times 1 is still what? 3. What is 5 times 1 is still what? 5 times 1. This one is from where? From this, abi? Hope you are aware. What do you have here? 3 times 1 is what? Yeah? 3 times 1. This one is from where? 1 times what? 1, abi? Are you following somebody? Now what? Between this, which is common among them? Which is common? Can I say this is the same as 1 equals to 3 in brackets? 1 plus 1 minus 5 times 1. So 1 equals to 3 times what here? 2. 3 times what? 2 minus what here? 5 times what? 1. Watch. Are you confused? Are you confused? I will explain. Now listen. Where is the confusion? Yeah, Abi? But you understand this part, right? Let me bring out this out again. 1 equals to what? 3, right? Times what? 1. Minus what? 5 times what? 1, Abi? Plus what? 3 times 1, right? This is same as what? 1 equals to what? 3 times 1 plus 3 times 1 minus 5 times 1. I've not done anything here. I just rearrange. I bring these two together since they are the same, Abi? 3 times 1 plus 3 times 1 minus what? 5 times 1. Is that clear? Now we now have 1 equals to what? What is common here? Eh? No, just bring that 3 as common factor. Understand it's 1. But bring that 3 as common what? Factor. When you bring that 3 here, what is many here? 1. What sign is this? Plus. What is many here? 1. Minus what? 5 times 1. That will give us 1 equals to what? 3 times 2. Minus what? 5 times 1. Is that the same answer? Are you saying it now? Is that okay? What's 1 plus 1 is 2. Minus 5 times 1. This becomes equation what? 5. Eh? Are you there? What do we say we'll do again? We will now put equation what? 3 into equation what? 5. Into the new equation you have. Are you getting it this here? Meaning, anywhere I see 3, I will put what? This, Abi? Is that not? In equation 5, do we have 3 here? We have 3 here. Can we put it now? I watch. Topic. Now watch. We have to put what? 3 into what? Equation what? 5 says what again? Let's repeat again. 1 equals to what? 3 times 2 minus what? 5 times 1. Can we now put now? Now give us 1 equals to what? What's our 3? This, Abi. What we have 23 minus 5 times 4, Abi. All multiply with what? 2, Abi. With 2 minus what? 5 times 1. For what I've taught you. How do we expand this? 23 times what? 2, Abi. 23 times what? 2. What we have? Minus 5 times what? What is 4 times 2? 8. Are you seeing it now? This 2 is not multiplying 5. Actually, it's multiplying what? Just that 4. So what do you have there? Minus what? 5 times 1. Right? Times 1. So here we have 1 equals to what? 23 times what? 2, Abi. What is common here? 5. Minus 5 is common. Is that not? Minus 5 is here. Minus 5 is here. When you do that minus sign, the bracket becomes what? Positive. So what will be here in brackets? What do you have here? 8 plus what? 1. Abi? Is that not? Why is it plus? Because I've only factorized out what? The negative value. Is that not? Are you following? Where? From here? Or from here? From here. You understand what happened here? Between these two, what is common? Minus 5. If minus 5 is common, divide, what do you have here? Minus 5 times 8 over minus 5 will give us what? 8. What do you have here? Minus 5 times what? 1 over what? Minus 5 will give us what? 1. This is another way to get it. Since I factor out what? Minus 5. Divide the whole of this with that minus 5. What will remain? 8. Divide the whole of this with what? Minus 5. What will remain? 1. Are you there? And that will give us what? 1 equals to what? Yeah? 23 times what? 2. Minus 5 times what? Yeah? 9. Equation what? 6. What will I do now? The last part should be, I will put what? 4 Abi into equation what? I will put equation 4 into 6. Equation 4 into equation what? 6. 4 Abi into what? 6. Now let's put, what equation 4 saying? This, right? Can we put? Let's repeat equation what? 1 equals to what? 23 times 2, right? Minus 5 times what, yeah? 9, right? That will give us what? 1 equals to. Where we are going to put what? Anyone will see 5, right? We put this value. Is that clear? That will give us what? 23 times 2 minus, in bracket, don't forget, minus everything here. What is the value of that 5 there? 120, minus 23 times what? 5, right? All times what? 9. Are you seeing the way I'm doing it now? Is it making sense gradually to you? Now let's finish up this. What do you have there? 1 equals to what? 23 times 2. What do you notice here? I've generated something similar, right? Oh yeah, what? Let's evaluate this. Minus. What will be here? Minus 120 times what? 9. Thank you. What will be here? Plus 23 times, what is 5 times 9? 40 what? 5. Are you getting the gist here? So this is the same as what? 1 equals to what? So 3 times 2, right? Can I do it together? Plus 23 times what? 45. Are you seeing it? Minus 120 times what? 9. So 1 is equals to what? Yeah? What is common here? 23. What will be here? 2 plus 45. Minus 120 times what? 9. So 1 is equals to what? 23 times, what do you have here? 47 minus what? 120 times 9. Then recall that we are told that our D is equals to what? 120 x1, right? Plus 23 s what? 2. You can tell me what will be our S1 and S2. What S1? No? minus 9. What's our S2? 47. How do we get that? We compare, right? This equation what? So what is this? 7, right? This is the given equation, right? What do we do when we compare? We do what? Compare. Compare both equations. When you compare them, I'm comparing this with this. Then I will now compare 2347 with what? 23 what? S2. If yes 23, yes what? 23, Abi? Yes what? S2. What will be the value of S2? 47. That means my S2 is what? 47. Let's take that of S1. What do you have here? Minus 120 times 9, right? Here we have what here? 120 S1. So when you remove 120, 120, what's remaining here? Minus what? 9. That means what? Our S1 is what? Minus 9. Final what? Answer. Now we are given that D equals 119U plus 544V. The first thing we have to find is the GCD of what? 119 and 544. And find the value of what? U and what? V. Looking at this, we can bring out prime factor of this, Abi, and this. So we can use what to solve for GCD. We can use the Euclidean what? Algorithm method, right? Are you following? Okay. Just recall that GCD of two numbers is given as what? A equals to what? B2 plus what? R. Where is greater than what? There? B, right? So between 119 and 544, which is our A? This, Abi? This is what? B. Now watch. A is what there? 544. Equals to what's that B there? 119. So I'm looking for what? My quotient and what? Remainder. So divide 544 by 119. What do you have? Huh? 4 point something, right? Is that not? Meaning my quotient is what there? 4. Remainder what? How do you find the remainder? Multiply that 4. That 4 by what? 119. What do you have? 476. Subtract that number from what? 544. What's the remainder there? Huh? 78. Are you sure? 68 or 78? 68. Thank you. So what do we do again? We have to extend, Abi. We extend this here. We extend this here. I'll keep on dividing until we have 0 what remainder. So here becomes what? 119. Here becomes what here? 68. Let's find what our quotient plus what? Our remainder. To find quotient, I'll divide 119, right? By what here? 68. What do you have? 1 point something, right? Meaning my quotient is 1. Remainder what? How do you find remainder? Multiply 1 by 68. What do you have? 68. So 119 minus 68 is what? So plus what here? 51. Are you there? We see how the remainder, right? It means I will extend again. I will do what here? Extend. When you extend, what do you have? Here becomes what here? 68 equals to what? 51. What's our quotient and what's our remainder? Divide 68 by what? 51. What do you have? 1 point something again, Abi? So we have 1 remainder what? 17. How do you have 17? 1 times 51 is what? 51. Subtract that value from 68. What do you have? 17. So I will extend, right? What will be here? 51 equals to what here? 17. Times what? Huh? Divide 51 by 17. What do you have? 3 point something, right? 300. Remember what? Okay. So we have 3. Remember what? 0. Which number comes before this 0? 17. So that means my GCD is what? 17. I mean, this is my GCD here. Are you there? Our GCD. Therefore, the GCD of what? 119 and what? 544 is simply what? 17. Sometimes we don't do this kind of thing. Say, evaluate this. This means what? Find GCD of what? 119 and what? 544. Sometimes I will put what? 544. Put what? 119. It's the same thing. Just identify your what? Your A and your what? B. Your A is always what? Greater than what? B. My A is what? 544. My B is what? But we're not done. We now have to find your unknown, Abi. Are you getting it now? Okay, so we have to rewrite. Rewrite what? The equation starting from GCD. Now let's revise. I'll make these numbers here 17, 51, 68 as what? Yeah, to stand alone, right? To stand alone, here becomes 17 equals to what? What do you have here? What do you have here? 68 minus what? 51 times what? 1. Equation 1 is this? 1. We'll make all of this to stand alone as the subject of the formula. So for this, what will here become? 51, right? Equals to what? Yeah? 119 minus what? Yeah? 68 times what? 1. Equation what? 2. What about this? 68 equals to what? Yeah? 544. Minus what? 119 times what? 4. Equation what? Yeah? 3. So what do you do? Can tell me the next? Backward what? Yeah? We have to do backward substitution. I will backward substitute the equation. Are you there? Starting from where? I will put equation what? 2 into equation what? 1. We have how many equations here? 3. I will put 2 into 1 and generate a new one called equation what? 4. Then put 3 into equation what? 4 to generate what? 5. I think this one is more simpler than the first one. Right? That first one we had about 4 equations, right? Or is it 4 or 5? 4, yes. I didn't get. Therefore, the previous one is different from this one now. This one is a different question entirely. Here we have 1, 2, 3, 4. But after the right, starting from the GCD here, meaning 17 equals to this, and 51 equals to what? This. Then this equals to this. But that first one, sometimes, like I said, sometimes you can have like almost 5, 6, 7, 8, or 9 sometimes equations, depending on the value of what? Of your A and what? And B. Are you getting the gist here? But yeah, yes. You can still be given minus. Your emphasis will still be on what? 119 and what? 54. But you now find your linear combination. No, it won't affect here. If anytime you have it, will not affect anything you are doing here. Don't bring that knowledge now. If here, if here is minus, does not affect, and just do your normal calculation here. When you now get your linear combination, you now compare your equation with what you have here. You remember now. Now we backward substitute, meaning we have to put we put what? Equation 2 into what? Equation 1 Let me get equation 1, 17 equals to what? 68 minus what? 51 times what? 1 So I'm putting equation 2 into 1, meaning anywhere I see 51, I'll put this Do you have it here? Right? Now what? Let's go. What will it be? 17 equals to what? 68 minus, in brackets. What's 51? This. Give me the value. 119 minus 68 times what? 1. All times 1, All times what? 1. Are you following? We have 1 here, This one is this one here. 51 is what we have here. Why are they in brackets? Because of this minus sign. Can we expand now? So we have 17 rather equals to what? 68 minus 119 times what? 1. What is 1 times minus here? Plus, right? Plus what? 68 times, what is 1 times 1? 1. Are you following? If I'm expanding this, here become minus, 119 times 1 is what? 119 times 1. What is minus times minus? Plus. Now to expand this one, here becomes what? Plus. Right? Plus what? 68. 1 times 1 is what? 1. Exactly. Now let's continue. Then we say this can also be what? 17 equals to what? 68 times 1, I'll explain. Just watch. 119 times what? 1 plus what again? 68 times 1. You know why we have to do that? Because I want to combine this and this together. 68 times 1 is same as what? 68. If you look at this here we have times 1, Here is what? Times 1. Let's make them to be like the same by putting what here? Times 1. I didn't alter anything. I just added what here? Times 1. Because 68 times 1 is still 68. Even if I have times 2, here remains what? Times what? 1. Are you getting it? Now let's watch. Between these two, what is common there? 68, we have 68 is common in brackets. Or let me group them together. Let's call them like terms, What are like terms here? 17 equals 68 times 1 plus 68 times 1 minus 119 times what? 1. So here we can say 17 is equals to what? 68 in bracket. Abi? If 68 is common among them, divide 68 times 1 by 68. What's remaining there? 1. Abi? What sign is here? Plus. Divide 68 times 1 by 68. What's remaining there? 1. Are you getting the gist here? Or the other way we can do it is, since 68 is common, bring it out. Abi? What's remaining here? 1 plus what? 1. Are you getting it now? Minus what here? 119 times what? Times 1. Abi? So what do you have here as final value? What the final value here? 17 is equals to what? 68 times what? 2. Minus 119 times what? 1. This equation what? Equation what here? Are you sure it's 4? 4, right? Okay. I'll put this out. So the next is that we do what here? We'll now put equation what? 3 into equation what? 4 into this equation 4. You know we put 2 into 1 to generate what? 4. I will now put what again? 3 into what? 4 to generate what? 5. So let's go. What is equation 4 saying again? 17 equals 68 times 2, Abi? Minus 119 times what? 1. So we have 17 equals to what? Let's put equation 3. What is equation 3? This, Abi? Into what here? Into this 4. Meaning anywhere I see 68. I'll put this, right? So let's go. What is 68 representing here? 544, minus 119, right? 119, times 4, right? All multiply with what here? 2, right? This 68 you are seeing here is this. The whole of this here is 68, which is this. Then we still have what here? 2. Is that clear? So let's finish up. So what do we have here? Minus 119 times what? 1. So this is what? 17 equals to what? 544 times what here? 2. Minus 119. What is 4 times 2 here? 8. Times what? 8. Minus 119 times what? Times 1. I explained it before now that if we are expanding, when you're expanding, this becomes 544 times 2. If I'm expanding this 4 multiply just what? This 2. Not this 119. The 4. What's 4 times 2 here? Is 8. Minus what? 119. Now let's watch. So we have 17 equals to what? Yeah? 544 times 2. Abi? Between these two, what is common? Minus what? 119. Is common. If I'm to factor out minus 119 out, what's many here? 8. What will here? Plus 1. Why is it plus 1? I've already factored out minus, right? So that will give us what here? Our 17 equals to what? 544 times 2 minus what? 119 times what? 9. This is equation what? Equation 5. Then we have to still recall what was the equation given to us. I've cleaned it already. D equals to what? 119 U plus what? 544 what? V. So I'll do what? I'll compare. Compare. When you compare this with this, I'll compare 119U with what? This, Abi? Compare what? 544V with this. Here we have 544, we have 544. What is your V here? 2. Is that clear? So my V here is what? Is 2. If I'm to compare this with this, if I'm to bring out what here? 119. What's many here? Minus 9. That means my U is what here? Minus 9. Is that clear? Another way to compare, let me show you. In case you want to learn this. Let me just add to your knowledge. Comparison simply means I will bring out here. What do you have here? 545 times 2, right? Is equals to what? 5 what? 4 times V. This can go with this. V is equals to what? 2. Are you seeing it? When you compare again, for this one, minus what? 119 times what? 9 is equals to what? What is it? 119, 119 what? U. If this should go with this, what's many here? So my U equals to what? Minus 9. Anyhow you are doing it.